Hey everyone, it's that math magician. On this video, we're going to take a look at an introduction to the law of cosines. We'll introduce what that is, when we should use it, and more importantly, how can we use it to help us solve for a missing side or a missing angle in a triangle. So let's get right into this video so we can look at a great example of why we need the law of cosines. Now you might be thinking to yourselves, we already have the law of sines, and the law of sines is very helpful because we know how to find the side or an angle now for any given triangle. And you're right, the law of sines is super powerful and we love it when it works. But sometimes it's not going to work. And for that, we're going to need to know the law of cosines. So let's take a look at the example that I have here on the left. We see we have a triangle here where I know some sides and I know an angle. It's definitely not a right triangle, so we know I can't use normal, sine, cosine, or tangent. I see that I do know two sides of this triangle, and I want to find the third, so you might be thinking Pythagorean's theorem would be super helpful here. But again, we can't use that because this is not a right triangle. So the only tool that we have under our belt at the moment is the law of sines. And so I just want to show you why, for this particular triangle here, that the law of sines actually fails us. Before I get into that, a quick recap that capital letters on a triangle represent the angles. I see angle A, angle B, and angle C there, 17 degrees. And the lowercase letters do represent the sides. And remember, those lowercase letters are the sides that are opposite from the given angle. So for example, capital A is here. That's angle A. That means A equals 13. This is the lowercase a. Same thing over here. There's angle B. I see that the side across from angle B will be 41. So that was what we would call lowercase b. And we see there that that already is our lowercase c. So let's see if we can use law of sines. I'm interested in finding side of C, so I'm going to use the sine of this angle here, so I'll try to set it up. Sine of my angle C, well my angle there is 17 degrees, over the side of C. So far so good. I got a fraction, I have my variable, I just need to make this equal to another fraction involving a side and an angle so we can cross multiply and solve. So let's see why this is gonna fail us. I see that B equals 41, so I could put 41 underneath there, but do you recognize that I do not know what angle B is? There's no value there. So if I were to put B here to represent that angle, if I tried to cross multiply that, we would end up with two different variables in one equation. It would be impossible for us to solve for angle B. The same thing can be said about when I try to use the side 13 for A. If I put the 13 there on the bottom, I quickly recognize that there is no angle here for A. So if I were to write the A there, again, two variables with one equation, it's just impossible for us to solve. So we've ran into a problem. Law of sines is failing us. And we don't yet now have a way to solve for that missing side of C. But the good news is that that's where the law of cosines comes in. Now I could spend time on this video proving why it works, but it involves a lot of math that really isn't important to how we use it. I might save that for a different video. So just for now, you'll have to believe me that this formula works for the law of cosines. And like I said, maybe in another video we can check it out. Now, a lot of times when students see this problem, they immediately jump to Pythagorean's theorem. They go, oh, I know two sides, so why can't I just use a squared plus b squared equals c squared, right? As I have it written out there, right? I'm trying to find out what c is. I know what a is. I know what b is. Why can't I just use Pythagorean's theorem? And the reason why we can't is because that is not a right triangle. But what's really nice is that law of cosines actually involves the Pythagorean theorem. The reason why I wrote this out here is because this is how the law of cosines starts. if we're trying to find out what a side is, in our case c, it starts off as c squared equals a squared plus b squared. But there's one other thing we have to add in there because of the fact that it's not a right triangle, and that last expression that we need to add is a minus sign, and we need to subtract out 2 times a and b and the cosine of the angle c. Now I already know that some of you are looking at that and going, whoa, that equation up there looks very complicated. I promise you that it's not that complicated, as long as you know which pieces that you need to put where into that formula. Okay, this tells us that we can find C now. C is representing the side on this triangle that we don't know. All I need to know are the other two sides, A and B. You notice here that I'm using A and B. Over here, I'm also using A and B. And then I just need that angle that is across from that side, which I do know. I have all three pieces that I need. I have the side A, the side B, and the angle C. This is going to be enough now for us to solve for that missing side of C. So all I'll have to do here is put in or substitute in the values that I know for A, for B, and for the angle C. So I know that angle A here is 13, so I'm going to change A to be a 13. So we have 13 squared plus the side of B, which is 41. So that becomes 41 squared minus 2 times the side A, which is 13, times the side B, which is 41, times cosine of our angle that opens up to our missing side, which in this case is 17 degrees. Does that look like a mess right there? I would totally agree with you there. But what's really nice is that we have very sophisticated scientific calculators that we can just enter in this entire expression in, and it will tell us what our answer is. Now, you might have some teachers who actually want you to solve this by yourself as much as possible on your own. If that's the case, then you would just need to get your calculator and you would need to start plugging in these numbers to simplify. Now, I don't require that in my classes, but like I said, your teachers might require you to do that. So what I'm going to do is I'm going to first solve it by showing you the short way. I'm just going to enter that expression into my calculator, and then I'll just talk you through how you could show it the long form way. Okay, so I see that c squared here represents this entire expression, so I'm just going to enter that into my calculator as I see it. So I'm going to type in 13 squared plus 41 squared minus 2 times my first side of A, which is 13, times my second side of B, which is 41, times cosine of my angle 17 degrees. Like I said, the reason why I love using scientific calculators is we plug that whole expression in there. Look, that expression is so long that I can't even see the 17 degrees there. But we know now that that whole expression here ends up equaling 830.579. So I know that c squared here is going to end up equaling, and look at that, I already forgot what it is, 830.579. Now to get what c is, all I need to do is take the square root of that number, and I will know what my missing side of this triangle is. It ends very similar to Pythagorean's theorem. We got to take the square root. So I open back up my calculator and I hit the square root button. Whoops, not twice. I hit the square root button and I enter in 830.579, and we see that that missing side is approximately 28.820. And there you go. We have now solved for that missing side of the triangle. When Law of Sines failed us, we can now use Law of Cosines only if, and there's a big if here, only if we know the two other sides and the angle that opens up to it, okay? If those are satisfied, the two sides and the angle that opens up to the angle, then law of cosines is your formula, okay? I want to real quick end, like I said, I teach this that you can just plug that into your calculator. There's less room for error when you do it that way. Some teachers might want you to do this by hand. So you would have to type in 13 squared. That makes 169. So you would need to show 169 plus 41 squares. Now I'm going to erase this and type in 41 squared. Whoops, 41 squared. That ends up being 1681. And then they want you to put all of this into the calculator and figure out what that is. As you can see, there's a bigger chance for error there. And again, for my classes, I do not require that. But if your teacher does, you need to go step by step, combining your like terms. And eventually you will get to 830.579. But I think it's a lot nicer and a lot cleaner just to enter in that expression to get 830.579. All right, guys, it's that math magician, and I'll see you on the next video.